My name is William Nordmann. I'm a software engineer with Freedom Consulting. I've been working in GA in the geospatial community for 20 years, doing aeronautical charting, foundation GEOINT, OpenSearch GIS, satellite imagery. Today, I'm working the Sabre contract, sitting alongside government DevCore developers to develop software. I'm going to talk about artificial intelligence, give some example of how it's used, how it's going to take your job, and how it's going to make it easier. I'm going to start with chatbots. Large chatbots are also called large language models. These are best known examples are ChatGPT and Bard. Chatbots work by using models trained on publicly available text, Wikipedia, Reddit, Stack Overflow, public domain books, anything and everything they can find. This huge breadth of knowledge gives chatbots good general knowledge of the world. They have the appearance of intelligence. They fill in text, but they don't really know anything. Chatbots work by reading the context of what's been typed so far, the question asked, and then guessing what should go next. This makes really good guesses, but it's not true intelligence. With this general understanding, chatbots are great at writing a polite note to a coworker, social media post, a yearly review, or outline a report. Chatbots have a tendency to be overly verbose, repeat themselves, or get lost with very complicated details and technical documents and make up answers. This make-up answers is referred to as hallucination, which is a real problem with chatbots. This should be tracked if you're doing something technical, and you should make sure to validate that the subject is correct. A solution for this hallucination is to train a chatbot on specific documents. If you have an organization with standard operating procedures, training manuals, technical procedures, documents, and manuals, these can be used to train a chatbot to generate specific answers. With this, you can remove a trainer from worrying about how to answer a question. Let the chatbot answer the generalization questions from day-to-day operations. Another popular use for AI is AI-generated art. DALL-E, Midjourney, Stable Diffusion are all very popular tools at this. They take a prompt, either text or an image, to generate a new image by guessing what the next pixel will be. These tools have been used to generate images for kids' books, logos for businesses, and won art contests. The AI art starts bringing up the question of what is an artist? Is an artist the person who holds the paintbrush, or is it the person who can see the art inside the paintbrush? This is a question that challenged portrait painters when cameras became popular, and it challenged photographers when Photoshop became popular. Generative AI, a graphic designer can generate an image, run it through generative AI as a prompt, and generate dozens of variations quickly. This allows the graphic designer to make more work quicker with less effort. Artist veteran and retired quality assurance analyst Gavin Heck uses AI to experiment with how to paint his paintings, how to lay it out, how to compose. He uses Stable Diffusion with different prompts to see where things go. This allows him to quickly understand where he wants to use a space and produce paintings quicker. He's gone from producing one painting in 3 months to 40 paintings in 1 month. This is 100 times improvement of his painting output by using AI. Another field of AI is computer vision. Computer vision is focused on detecting what is inside of an image. This application is self-driving cars, augmented reality, medical imagery, and optical character recognition. A baker in Japan started a project to detect what pastries are customers buying to augment the checkout process. This pastry AI became so good at detecting textures and shapes that it is now used in the medical field to detect cancers and anomalies in MRI scans. When we talk about image detection, satellite image comes up in the GIS, the geospatial community. Using AI techniques of image detection, we can apply that to a satellite image to detect boats, planes, cars, tents, whatever we need. An AI can direct an analyst to a part of the world that has more tents than usual and help the analyst detect displaced peoples. With training, the AI can go further. You can know what is a boat, and then we have fine-tuned training to say what type of boat it is on the subset of boats. The days of imagery analysts squinting at a screen to look for changes and count how many objects are there and are quickly replaced by AI telling imagery analysts, this is an interesting part of the world, this is where you should look and see what's going on. Segmentation is a more general approach to AI. Segmentation finds objects in an image and generates the shape of the object as vector data. In satellite image, segmentation we use to separate buildings from roads or plants. and generate vector data for the roads and buildings. Then this vector data can be used as foundation GeoINT. Facebook recently released Segment Anything model, SAM, to quickly detect buildings and manually use to select roads with very little training. Tools like SAM can speed up remote sensing. The effort it takes to collect features from a satellite image or load them into database was greatly reduced on the analyst to focus on quality over quantity. AI is here to help you with your job, remove the mundane parts, and allow you to focus on the interesting part. No more worrying about how to write an email, where to find the best cat photo for your presentation, reading a boring document for minor details, or counting pixels on an image. Embrace AI. Enjoy the future.